All right, 7:6. This is the last section of this chapter, okay? So we will be done this chapter after this lesson. It'll probably take us 2 days to do this one. So we'll probably only do about half of this today. All right, but that's okay. Let's review a little bit. You guys ready? Doesn't sound like it. Here we go. Let's review some formulas, because there are formulas you're going to have to know. Okay, these are real basic formulas. You probably, some of you anyway, probably could have walked through this door the first day of school and already knew what these formulas are. All right, and we may have even talked about a few of these in the past. C, standing for circumference. Now we're talking about circles. So what do we mean by the circumference of a circle? What does that mean? What about the entire circle? It's not the area. It's not area. It's circumference. What's circumference? What is the outline of it? If you walked around a circle, okay? If you walked around the edge of the circle, that's the circumference of a circle. Okay, not going through it.
Jonathan George, Cam Harkins, Megan Katona Farmer, Juliana Knight. Thank you.
All right, goodness. All right. I'm just going to give you the formulas. We're going to talk about something in a little bit, but here we go. It's 2 pi r. That's basically how you should memorize this formula, or you could remember it, pi times the diameter. Usually we write pi times the diameter first, but I wrote 2 pi r first. Right? What does that mean? Well, I'm glad you asked. Let's talk about it. Circumference. Again, what does the circumference mean? It means the distance around it. That's right. So circumference means the distance around. So if I started right here and I wanted to find the circumference of this circle, if I walked all the way around it or just figured out the distance, okay, all the way around it, that would be the circumference. All right, now it's kind of hard to measure. Why is it kind of hard to measure? Because it's a what? It's a circle, all right? It's rounded. It's kind of easy to measure straight edges, isn't it? All right, what would be one way that you could probably measure a circle? What if I brought a big old circle in here and I said, okay, measure the circumference of that circle? Would you take the tape measure and try to wrap it around very carefully? I guess you could, but it'd be hard. But nah, you're not going to use a compass. What if I have a big old circle like this? You don't have a compass as big as that. All right? And a compass doesn't even give you the measurements anyway, but it does make a circle. I used to have a blackboard compass. We don't even have blackboards anymore. We have whiteboards, but it used to be wood, and it was like this long. You put it on there, put a piece of chalk on there, and you could make a circle out of it. I used to use that for years and years. But anyway, now I'm using a computer. Who would have known back then? What if I gave you a circle? A big old round circle, okay, like a big old plate or something, right? That you serve food on, you know, like a big giant tray, and it's a perfect circle. How could I measure the distance around that circle? What would be an easy way to do that? Like with stuff that we might have. I actually got a little bit in my drawer right there. I could use something. You could do that, okay? You're getting ahead of me, but you're absolutely right. You could. We'll talk about that in a second. But what's an easy way that I could measure around the outside of the circle? I could take a piece of string, right? I could take a piece of string, right? And take it and wrap it around, right? And then what would I do with that string? I'd pull it out straight, right? And then I could measure a straight line, couldn't I? It's easy to measure that. Agreed? All right. So the circumference is basically a straight line, but it's just going around in a circle. Make sense? So it's a distance, right? So if this was in inches, what if the radius was in inches? Then my circumference would be in what? In inches. If it was in centimeters, it would be in centimeters and so forth. Everybody got that? All right. What is the R? What does that represent? I should write these down, shouldn't I? Circumference. All right? And the R is the radius. What's the other one I didn't tell you? The D. And that, yeah, you should know that. It's diameter. What's that weird looking thing right there? That's pi. Okay, what is pi? 3.14. Now watch, I'm going to put a little squiggly equal sign. Why do I put a squiggly equal sign? It's approximately, that's the word I want you to use. It's approximately 3.14, okay? Where does that number come from? Well, I'm glad you asked. Kate kind of alluded to it a little bit, so now we're going to talk about it. Let's use this, circumference equals pi times diameter. In fact, let me write it right here. What if I was going to do a little brief algebra, just one little step, and get pi by itself? What if I wanted to get pi by itself to see what it's equal to? What would I do? What would my algebra be? Divide by the diameter, exactly right. So if I want to get pi, when I keep pi right there, I would divide by the diameter because it's being multiplied, correct? So what is pi, whoops, I saw the C and I put a C. So what is pi equal to then? It's the circumference, what? Divided by the diameter. So if I used to do this, in fact, I probably still have these little cups and I'd have a piece of string, but we just don't have a whole lot of time today. So if I was to, I have these cups, right? And if I wanted to find the circumference of the cup, what would I do? I'd wrap a piece of string around it, right? And then either cut it or mark it or something, stretch it out, and then I'd measure that circumference. Then I could measure the diameter. What's the diameter? It's all the way through the center. It's from one end of the circle to the other, but it has to go through the center. That would be the diameter right there. Then I would measure the diameter. And guess what I wouldn't get it exactly, but guess what I would get really close to? I'd get really close to pi, which is what? 3.14, okay? So every time we did it, we would do it with different sized cups. We'd take this bigger cup, a medium one, and a small one. We'd wrap a string around the big one, measure it, measure the diameter of that same cup, and then we would divide. Whatever the measurement of that circumference is, whatever the measure of the diameter is, we would divide it. And almost every time, we would get pi to be just a little bit more than what? 3, right? So 0.14 is just a little bit more than 3. That's one way to get an approximation of it, all right? We would never get 3.14. Didn't I show you the video before break about pi and what they went through to get all the digits and that kind of stuff? Oh, I didn't show you the other one? Okay, maybe one day remind me, maybe I'll show it. Yeah, just watch the video and I'll show it on there. We're up to date. So Wednesday, whatever Wednesday is on the, what do you call it? Lesson plans. Why do I always forget that? I don't know why. All right, anyway, I think it's kind of interesting. You can take any circle. It doesn't matter how big, how small. If you take the circumference and you take the diameter and you divide them, it will always, always, always come out to be a little bit more than 3. All right? I think that's pretty cool. So there's a lot more we could talk about pi, but that's all I want to talk about pi for right now. Let's talk about one more thing. Let's talk about the area. So the area is different than the circumference. What is the circumference? It's the distance around it. If I was going to walk around the circle, that would be the circumference. What in the world is the area? If I was to do this, if I was to break this circle, I'm not going to do it very much. If I was to break this circle up into a bunch of squares, let's pretend, again, I'm not going to do it. I'll just do it. And then let's say from there to there, there to there. You get the idea? I could keep going. I'm just not going to because I just don't want to waste time with this. But if I kept going, you'd have a whole bunch of squares, right?
Please come to the office.
What is going on today?
Eliana Halliday.
Almost looks like a guitar, doesn't it?
Begging to the farmer.
So the area, I'll just say this. Pi r squared.
Noah Lukasavich. Amon Masala. Caleb Metzger.
A lot of people get these mixed up.
Montgomery. Thank you.
Oh, goodness. Thank goodness. All right, here we go. So the area is pi r squared. You can always remember pi r squared because area is always squared because we're finding out what? How many squares are inside of here, okay? So when it's squared, it's always what? Area, okay? It's always the area. But you look, there's going to be these, see, there's no way you can get that to be a square, right? Because you're always going to have a curve right there. Even if you make them really tiny, tiny, tiny small, you're still going to get a bit of a curve. So that's why you're always going to get a little bit of a decimal with this. All right, it's not going to come out to a nice even number. I don't think it ever comes out to a nice even number. All right, because you're always using pi, and it will never come out to an even number. By the way, that 3.14, does it stop right there? Nope, it keeps going. It goes 1, 5, 9, blah, 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 whatever is after that. And it goes on forever, never stops, never repeats. There's a couple times it might repeat one number, but it doesn't like keep repeating over and over again, okay? So that's what pi does. So the area is pi r squared. You got to remember which one's which and what they do. Circumference, what are we doing for circumference? We're finding out how far around the circle it is. Okay, so that's just, if it was in centimeters, our answer is just in centimeters. But what if the radius was in centimeters and we wanted to find the area? What's our answer going to be in? What are the units of my answer going to be? It's going to be centimeters what? Squared, right, because you're finding out how many squares you have. Everybody got it? You understand the difference between the two? All right. A lot of people don't. A lot of people, I mean, they were probably taught it, but they just don't remember the difference. So here's what we're going to do. Example 1. They say find the circumference. I'll just put that. And find the diameter, area. I'll just put A for area. Okay, so we're finding that. Whose diameter, I got to show you one more thing I forgot to say. Whose diameter is equal to 10 meters. All right, so let's go back to this a second. I gave you two little equations here, formulas, whatever you want to call them. Let's take that. See that one diameter that I made, that first one that I made? And oops, I didn't start at the right place. Let's start right there and go to there. Close enough. All right, so you see that part, and then you got this part. I could get rid of all that junk, but that's good enough. So this right here, the blue one, is the what of the circle? It's the radius, okay? So that's the radius of the circle. What's the relationship between the diameter? Let me see if I can grab that blue one. What's the relationship between the diameter and the radius? So now the blue one is the whole entire what? Diameter. But from here to here is the radius again. So how many radii, that's the plural of radius, how many radii does it take to make one diameter? 2 of them, right? So 1 diameter is equal to what? 2 radii. Everybody see that? So instead of pi times diameter, what if they gave you the radius to it? It's just 2 times the radius. Do you understand? It's the same equation because 2 times the radius is the same thing as the what? Diameter. Everybody see that? All right, so that's why we got it. I should have said that earlier. I just didn't. All right. Now on this one, they tell you what the diameter is. If you really wanted, which we're going to have to do on number 10, number 10, for the area, we're going to have to find the radius. So if the diameter is 10, what's the radius going to be? It's going to be 5. That's right, because the diameter is twice as big as the radius. So the radius means it's half of the diameter. You with me? It's 5 what? Meters. That's not what they ask for, though, is it? But I got 2 equations. One uses diameter, so I could have just gone pi times diameter. But most of the time, we're going to write circumference like this, 2 pi r. That's the one that you need to get used to. Okay, the circumference is 2 pi r. What did we say the area was? Pi what? R squared. So what's really important on both of these equations? Finding the what? The radius, okay? That's why we took it from diameter to radius. So now I'm going to take that radius and just plug it in. So let's find the circumference. It's 2 pi. I'm just going to keep that pi for right now times the radius. What is the radius? Well, the radius is 5. It's not 10, it's 5. Okay? And now you can do the math. Circumference is, watch what I'm going to do. I'm going to go 2 times 5, which is 10. 10 times pi. Now in a math class, I think it's perfectly fine to keep it 10 times pi. Okay? But in real life, you probably want to multiply it out. How would I multiply that out? I would go 10 times what? 3.14. That's right. And don't take it a whole bunch of decimal places. Don't put it into your calculator with the pi button. Okay? Don't use the pi button on your calculator because it takes it out like, 6, 7 places, 8 places, maybe something like that, depending on your calculator. So don't use the whole pi button on the calculator. There is a button on most calculators. If you click it, it'll take it out like, I don't know, 8 decimal places, something like that. Don't use that, all right? I want everybody to stay consistent and just use 3.14. Everybody got it? So whenever there's a pi, always use 3.14. Don't use the button on your calculator. Now, that's easy to do the math right here. Can you do 3.14 times 10? What is that? 31.4, okay? That's the circumference. Technically, these should be squiggly. Why should they be squiggly? Because this is an approximation. It's not exactly 31.4. It's approximately. That's why I put squiggly equal signs. We good? All right, that was easy enough. Let's do area. It's not much different. A little bit. So we got the pi, so I'll just keep it pi. The radius squared. So what is the radius of this thing? It's 5. What are we doing to the radius to find the area? We square it, okay? So the area is what? What's 5 squared? 10? 25. It's 25. I always put the number first, then I'll put the pi. You could just keep it like this. I would be perfectly fine if you kept the answer like that for circumference. I would be perfectly fine if you kept the answer like that for area, right? Now it is in meters, so what? And I forgot here too. These are in meters, so this should be just meters because it's circumference. This should be what? Meters squared, okay? Or you could stick it into a calculator. So you could go 25 times 3.14. There's no way I can do that in my head. So I put that into a calculator. I've already done it. So it comes out to 78.5. It's in meters, but it's meters what? Since it's area, it's squared. So you could keep it like that. Again, squiggly equals. I would not mark it wrong if you just put equals, okay? But you should technically put squiggly equals. There may be a word for that. It's just the approximate symbol. Okay, question? Saw a hand up.
I was going to say, every time I go to put in weights, it always comes out as fraction.
Yeah, it depends on what calculator you're using. Some calculators will put them in as fractions. Some won't do that. It just all depends on what calculator. So I would try to change your settings on the calculator to make it go decimals. I'm sure there's a setting on there. I just don't know off the top of my head how to do that. If I looked at it for a few minutes, I'm sure I could figure it out. But you probably could too. So just try to figure out where the setting is to not turn decimals into fractions. Okay, I'm sure there's something on there. Used to be back in the day, no calculators could do that anyway, but now, yeah, they've made them a lot different from back when I was first using calculators. All right, let's talk about a couple more things. When did I say this is over? 15, 3 minutes. Okay, I can do this first page right here. Let's do this. Let's draw a few circles. And all we're doing is some vocab right now, all right? And let's draw that one, and we're not going to really do anything with them right now, but I just want to talk about them, all right? All right, let's find out where the center is. It's right there. Let's put a dot. There we go. So that was really all the math today we're going to do. Later on with this, I thought we'd be able to finish this lesson in one day, but obviously we're not. So this is A, B, C. All right, this little bit, BC, is the radius, correct? Now, there's an angle. See the angle that's formed? They both come to this dot. What's this dot? It's not just any old dot. What is it? It's the center of the circle. It's the center of the circle. So this angle, have we used theta before in here? Have we talked about that? Theta. It's a Greek letter of the alphabet, all right? So I'll do it a little bit bigger. It usually has a little swoosh through it like that. Looks like an Orioles O kind of thing, all right? They call that, it's a Greek letter of the alphabet, all right? And it's the Greek letter theta. We usually use that to represent an unknown angle, okay? It's a really common thing to do. So if you have an unknown angle, we usually use the Greek letter theta. Is that the first time you've ever seen that? Okay. It's not going to be the last because we're going to be using it a whole lot. There's other Greek letters in math that you use a lot, but that's the one that's probably the most common, or at least the first Greek letter that you learn, okay, when you do math. By the time I was finished being a math major, I mean, we had so many Greek letters for so many things. I think we might have used the whole Greek alphabet at some point. But anyway, that's the first one. It's theta. So this angle right here, theta, this angle is called the central angle. Okay, that's really important. We're going to refer to that a whole lot. That's the central angle.
For dismissal, any seniors still in the building, please come to the office and talk to Mr. Osborne about your senior captain project. Thank you.
Okay, let's do another one real quick. I know the bell's about to ring, but just give me a minute. All right. What if I did this? What if I filled in this area and it's not going to be perfect. All right. What if I filled in that whole area right there? What do we call that? We call that the sector, S-E-C-T-O-R, the sector of the circle. It's got to come to the center. Okay, I got one more and then we'll be done. Okay, so just bear with me just a minute, probably less than a minute. Let's put a center right here. Let's put another one right here. Let's put another one right here. Now watch this. This is a little different. Everybody watch. I'm going to connect where they hit the circle right there. Everybody see that? And let's see. Let's grab that. Let's grab this. Okay, now watch. Oops, not what I wanted. This and this. See that part right there? From that straight line where I connected those two, we call this the segment of the circle. Segment. Okay? And we'll talk more about it later. So we're done for today. We'll try to finish this tomorrow. So
Thank you.
I don't know if you're going to be able to do any homework. You might be able to do those perimeter and area ones. So the lesson is 1 to 10, 13 to 18. I'm not sure which ones are what because I don't have it in front of me. It's 1 to 10, 13 to 18. So do as many as you can. Okay, you probably will be able to do 1 through 10 is my guess. All right, but do as many as you can, and then the rest of them, the sector, segment, and stuff, we'll do tomorrow.